Kriegsmarine intelligence report that reached Grand Admiral Karl Dönitz's headquarters in Berlin during August 1943 contained naval aviation statistics that seemed to violate every principle of maritime aircraft construction and naval aviation manufacturing. The classified document claimed that American shipyards and aircraft factories had produced over 20,000 carrier-based aircraft in mere months, suggesting production capabilities that defied fundamental assumptions about precision naval aviation engineering and wartime industrial capacity. "This is impossible propaganda designed to demoralize our forces," Dönitz declared to his naval aviation staff, studying reconnaissance photographs of American aircraft carriers loaded with seemingly endless rows of fighter aircraft. Naval aviation requires specialized engineering that cannot be mass-produced like automobiles. These Americans must be constructing training mock-ups rather than combat-ready carrier aircraft. These were experienced German naval aviators who understood carrier aircraft production through years of meticulous engineering and specialized craftsmanship that had created Europe's most sophisticated naval aviation through systematic precision and technological excellence. The concept of assembly line naval aircraft seemed to violate fundamental principles of maritime aviation manufacturing that demanded individual attention over production speed. They had no way of comprehending they were witnessing the greatest naval aviation production program in maritime history, or that American factories would ultimately manufacture over 100,000 naval aircraft while revolutionizing carrier warfare through systematic abundance that would overwhelm German naval aviation excellence through unprecedented numerical superiority and continuous replacement capability. Grand Admiral Karl Dönitz stood aboard the aircraft carrier Graf Zeppelin in the Baltic Sea, observing precision naval aviation operations that embodied German confidence in maritime air superiority through innovative carrier aircraft design and systematic naval pilot training excellence. As Supreme Commander of the Kriegsmarine, Dönitz represented German assumptions about naval aircraft quality triumphing over quantity through superior engineering and professional maritime aviation standards. German naval aircraft production that Dönitz understood included meticulous craftsmanship, individual attention to maritime specifications, and systematic quality control that created superior carrier aircraft through careful engineering for naval operations. German shipyards produced naval aircraft like precision maritime instruments rather than mass-manufactured products, emphasizing technological excellence over production volume for specialized carrier operations. Messerschmitt Bf-109T carrier fighters and junkers, 87 sea dive bombers that German naval industry manufactured represented pinnacle achievements in maritime aviation engineering through sophisticated design, advanced corrosion resistance, and systematic development. German engineering had solved complex technical challenges specific to carrier operations that produced aircraft exceeding enemy naval capabilities through individual excellence. Intelligence analysis of Allied naval aircraft production suggested enemy forces remained constrained by conventional manufacturing limitations, specialized naval engineering requirements, and industrial bottlenecks that prevented rapid carrier aviation expansion. German naval planners calculated that Allied naval aircraft production would require years to match German technological capabilities while maintaining acceptable maritime performance standards. Strategic doctrine that incorporated German naval aviation advantages assumed technological superiority would enable continued maritime air dominance through superior carrier aircraft design and systematic naval pilot training. Democratic nations could allegedly never achieve rapid expansion and quantity-focused naval production approaches while maintaining individual aircraft excellence that characterized German naval aviation superiority. Economic calculations performed by German naval economists revealed Allied industrial capacity divided between civilian consumer production and military production, limited military requirements, suggesting resource constraints that prevented total conversion to specialized naval aircraft manufacturing. Aluminum allocation and skilled maritime aviation technicians appeared insufficient for massive carrier aircraft production programs requiring specialized naval engineering and precision manufacturing techniques. Cultural assumptions about American naval industrial organization suggested inefficient production methods and profit-motivated rather than strategically focused approaches that would prevent systematic naval aviation manufacturing. German naval ideology characterized democratic industry as wasteful and disorganized, compared to German systematic efficiency and specialized maritime technological discipline that prioritized individual aircraft quality over mass production. Technological advantages that German naval aircraft possessed included sophisticated carrier landing systems, advanced corrosion protection, and superior naval aerodynamic engineering that reflected years of systematic maritime development and operational experience. German naval aircraft had proven tactical superiority through mathematical combat effectiveness. Demonstrations in specialized carrier operations that exceeded Allied naval aviation capabilities. Combat statistics from early naval engagements seemed to validate German assumptions about naval aviation warfare effectiveness and technological advantages over Allied carrier forces worldwide. German naval aviation units had achieved remarkable success through superior carrier aircraft performance and systematic naval crew training that appeared impossible for mass-produced enemy naval aircraft to match. Strategic planning for extended naval aerial warfare assumed German technological advantages would enable victory through superior naval aircraft performance and systematic maritime pilot development that would overcome any potential quantitative disadvantages. Individual naval aircraft quality appeared more decisive than numerical strength in carrier operations, where specialized technological capability determined tactical outcomes rather than production volume. Roy Grumman, founder of Grumman Aircraft Engineering Corporation, walked through the sprawling Bethpage manufacturing facility, observing revolutionary production techniques that would transform naval aircraft manufacturing through systematic mass production methods adapted for carrier aviation. The civilian aviation industrialist was applying innovative production expertise to specialized naval aircraft construction with systematic efficiency that would fundamentally challenge German assumptions about maritime aviation manufacturing. The F-6F Hellcat program that American naval industry developed represented complete departure from traditional carrier aircraft manufacturing that emphasized individual craftsmanship over systematic mass production for naval operations. Hellcat design prioritized carrier compatibility, combat reliability, and assembly line production capability rather than technological sophistication alone, enabling manufacturing rates that completely exceeded German naval industrial calculations and strategic planning assumptions. Assembly line techniques that Grumman employed included revolutionary automotive production methods systematically adapted for complex naval aircraft manufacturing through organized workflow, standardized maritime components, and continuous production that eliminated traditional carrier aviation manufacturing bottlenecks. American industrial experience had created unprecedented manufacturing efficiency that surpassed specialized naval aircraft production through civilian innovation and competitive optimization. Workforce mobilization supporting naval aircraft production included revolutionary numbers of women entering precision manufacturing while maintaining comprehensive training programs that created skilled workers adequate for complex carrier aircraft assembly operations. Democratic educational systems produced abundant human resources through competitive instruction, merit-based advancement, and systematic maritime skills development programs that exceeded traditional naval aviation workforce limitations. Supply chain coordination across American naval aircraft manufacturing included specialized aluminum delivery from multiple continental sources, marine engines from dedicated manufacturers, and thousands of carrier-specific components from hundreds of subcontractors whose production was synchronized through systematic logistics management. Materials coordination exceeded German naval organizational capabilities through democratic industrial cooperation and competitive resource allocation that enabled unprecedented production rates. Quality control procedures ensured carrier aircraft reliability through systematic testing protocols, continuous maritime inspection processes, and rigorous naval performance validation that maintained combat effectiveness while enabling unprecedented mass production rates. American naval manufacturing had achieved consistent quality through scientific methods rather than traditional individual craftsmanship attention, proving that systematic approaches could maintain naval aviation standards while enabling mass production. Standardization that naval aircraft production achieved eliminated custom engineering requirements and specialized components that characterized German carrier aircraft manufacturing, enabling universal, interchangeable parts and simplified naval maintenance that reduced logistics complexity while increasing carrier operational efficiency. Systematic design created significant naval operational advantages through manufacturing forethought and engineering optimization that exceeded traditional naval aviation approaches. Innovation acceleration continued throughout naval aircraft development, as American engineers continuously improved carrier aircraft specifications while maintaining aggressive production schedules that traditional naval methods could never sustain. Competitive pressure encouraged rapid advancement that exceeded conventional maritime development cycles, while ensuring manufacturing compatibility and sustained production capability that traditional approaches could never achieve. Training programs for naval aviators paralleled production expansion through systematic instruction that prepared personnel for complex carrier aircraft operations while maintaining professional naval competence standards. American naval aviation created abundant human resources adequate for dramatically expanded carrier capabilities and operational requirements that would soon exceed German naval aviation capacity through systematic abundance rather than individual excellence. Strategic planning that incorporated massive naval aircraft deployment included comprehensive carrier tactical doctrine development and operational coordination that would maximize aircraft effectiveness across Pacific theater operations. American naval strategy integrated production advantages into comprehensive campaign planning that assumed virtually unlimited carrier aircraft availability and continuous replacement capability that would fundamentally alter naval warfare mathematics through industrial superiority. December 1943. German naval intelligence documentation of American carrier aircraft production revealed manufacturing statistics that challenged every fundamental assumption about naval aviation construction and maritime industrial possibility worldwide. American factories were completing over 1,000 naval aircraft monthly, while maintaining simultaneous production across dozens of specialized facilities that collectively exceeded total German naval aviation manufacturing capacity by extraordinary margins that seemed mathematically impossible. Mathematical analysis that German naval planners performed revealed American carrier aircraft production approaching 20,000 total units in mere months, while German naval aviation production struggled to maintain 2,000 specialized carrier aircraft across all naval manufacturers and facilities. Enemy naval industrial capabilities had achieved systematic abundance that completely violated traditional assumptions about precision naval aircraft manufacturing, complexity, and specialized maritime engineering requirements that German naval aviation had always considered fundamental limitations. Statistical verification through multiple naval intelligence sources confirmed American carrier aircraft production that included standardized naval components, revolutionary assembly line manufacturing, and systematic maritime quality control that enabled mathematically impossible production rates for specialized naval aviation. Enemy manufacturing had achieved unprecedented efficiency that exceeded German naval industrial organization through democratic competitive methods and civilian industrial expertise applied to naval aviation manufacturing. Photographic reconnaissance of American naval aircraft factories revealed production techniques that completely eliminated individual naval craftsmanship in favor of systematic manufacturing approaches directly adapted from civilian automotive industry methods for carrier aviation applications. Democratic naval industrial organization had achieved military production through competitive rather than centralized authoritarian methods and systematic resource optimization that exceeded traditional naval aviation manufacturing approaches. Economic calculations demonstrated American naval aircraft expenditure that exceeded entire German naval budgets, while simultaneously maintaining civilian consumer production and comprehensive international assistance programs. Democratic capitalism had achieved resource abundance that centralized command economy methods could never duplicate through systematic efficiency and competitive innovation in naval aviation manufacturing that rendered German economic assumptions obsolete through mathematical evidence. Supply chain analysis revealed American naval aircraft manufacturing coordinated across continental distances with material flows that dramatically exceeded German naval logistical capabilities and organizational systems. Enemy industrial organization demonstrated systematic coordination that exceeded authoritarian central planning through competitive cooperation and democratic resource allocation methods in maritime aviation production that achieved efficiency through civilian expertise rather than military organization. Workforce demographics supporting American naval production included women, minorities, and civilian workers whose technical competence fundamentally challenged German assumptions about precision naval aircraft manufacturing requirements and skilled labor availability. Democratic society had mobilized human resources through inclusive participation rather than traditional hierarchical military organization structures, proving that systematic training could produce naval aviation manufacturing capabilities through competitive education rather than traditional apprenticeship methods. Technology assessment based on captured American naval aircraft revealed manufacturing quality that equaled German precision standards while being produced in quantities that German naval industry considered physically impossible without sacrificing performance specifications. Mass production had achieved consistent reliability through systematic scientific methods rather than individual attention and artisanal approaches that characterize German naval aviation manufacturing philosophy. Innovation integration throughout American naval production included continuous improvement in carrier aircraft design and manufacturing efficiency, while maintaining production schedules that traditional naval methods could never achieve or sustain. Competitive pressure had encouraged rapid advancement, while ensuring systematic delivery and performance optimization that exceeded traditional naval aviation development cycles through civilian industrial expertise applied to maritime aviation challenges. The statistical impossibility had become undeniable strategic reality that forced German acknowledgement of democratic advantages in naval industrial organization that exceeded authoritarian alternatives through competitive efficiency and systematic abundance in naval aviation production, that would fundamentally alter maritime warfare through industrial superiority rather than individual technological excellence or traditional naval aviation approaches. June 1944. The Battle of the Philippine Sea revealed devastating effectiveness of American naval aircraft production as over 900 carrier-based fighters participated in operations while maintaining strategic reserves that exceeded German total naval aviation inventory. The mathematical superiority of American manufacturing had translated into overwhelming carrier dominance that rendered German naval aviation philosophy strategically irrelevant through systematic abundance rather than individual aircraft excellence. Tactical deployment that American naval aircraft abundance enabled included multiple carrier task forces operating simultaneously across Pacific theater, while maintaining replacement capabilities that German naval forces could never match, despite individual aircraft superiority and pilot training advantages. American production had eliminated traditional naval aviation constraints through systematic abundance and continuous replacement that exceeded traditional maritime warfare limitations through industrial capacity. German naval observers discovered combat situations where destroying individual American carrier aircraft achieved minimal strategic advantage because American replacement rates exceeded German destruction capabilities through industrial production. Mathematical relationships had shifted decisively toward Allied naval aviation through manufacturing capacity rather than individual combat effectiveness or tactical excellence that had characterized traditional naval aviation warfare approaches. Combat statistics from sustained Pacific carrier operations documented German naval aircraft losses that could not be replaced, while American carrier units maintained operational strength through continuous production and systematic replacement programs. Industrial abundance had created tactical sustainability that exceeded German naval response possibilities and resource allocation capabilities through democratic industrial organization, rather than traditional naval aviation approaches. Intelligence analysis by German naval commands revealed American naval production capabilities that dramatically exceeded strategic planning assumptions, while demonstrating industrial organization that surpassed authoritarian efficiency through democratic competitive methods. Enemy capabilities had achieved systematic advantages that traditional naval military planning could not anticipate or counter effectively through conventional naval aviation approaches or resource allocation methods. Psychological impact on German naval pilots included recognition that individual combat excellence could not influence strategic outcomes when facing opponents with unlimited replacement capabilities and continuous reinforcement. Tactical victory had become strategically meaningless against American production abundance and systematic naval aircraft deployment that exceeded traditional naval aviation warfare mathematics through industrial superiority. Strategic implications of American carrier aircraft deployment included Allied naval capabilities that could absorb tactical losses while maintaining offensive momentum that exceeded German naval defensive planning and resource allocation. Abundance had eliminated traditional tactical considerations through systematic numerical superiority and continuous operational capability that rendered traditional naval aviation approaches obsolete through manufacturing advantages. Supply chain advantages that American naval production provided included spare parts availability, maintenance support, and replacement aircraft that sustained combat effectiveness under extended Pacific operations across multiple theaters. Systematic logistics exceeded German naval capabilities despite homeland proximity and theoretically superior interior transportation lines through democratic industrial organization and competitive resource allocation. Innovation acceleration during sustained Pacific operations included continuous improvement in carrier aircraft design and tactical employment that enhanced effectiveness while maintaining production compatibility and manufacturing sustainability. American competitive pressure had encouraged advancement through systematic development and performance optimization that exceeded traditional naval aviation approaches through civilian industrial expertise. The Pacific carrier battles demonstrated American naval aircraft production had fundamentally altered maritime warfare mathematics through industrial capabilities that rendered traditional naval aviation excellence obsolete when facing systematic abundance combined with adequate performance and continuous replacement capability that exceeded traditional naval warfare limitations through democratic industrial superiority. August 15, 1945. As Japan surrendered unconditionally following devastating Allied naval campaigns, the final accounting of American naval aircraft production revealed numbers that had redefined maritime warfare. Over 100,000 naval aircraft manufactured through revolutionary assembly line methods that averaged one completed carrier aircraft every 30 minutes at peak production, creating naval aviation capabilities that had overwhelmed Axis naval excellence through unprecedented systematic abundance. Strategic validation that American naval aircraft production provided confirmed industrial mobilization as the decisive factor in modern naval warfare, while demonstrating democratic advantages in manufacturing organization, resource allocation, and technological application that exceeded totalitarian alternatives through competitive innovation and systematic efficiency optimization. Democratic naval industrial organization had proven superior to authoritarian approaches through mathematical evidence that could not be disputed. Admiral Dönitz's post-war acknowledgement included recognition that German naval aviation superiority had been strategically defeated by American production capabilities that exceeded every calculation of democratic industrial potential and naval manufacturing capacity. Assembly line manufacturing had rendered individual naval aircraft excellence strategically irrelevant through overwhelming numerical superiority and continuous replacement that exceeded traditional naval aviation warfare approaches. Economic efficiency that American naval aircraft production achieved included dramatic cost reduction through volume manufacturing, while maintaining combat effectiveness that exceeded traditional naval aviation development methods. Competitive capitalism had proven systematically superior to command economy organization for sustained naval military production and technological advancement across global naval operations through democratic resource allocation. International cooperation through American naval aircraft deployment included comprehensive transfers to Allied naval forces that enhanced collective naval aviation capabilities while demonstrating American production capacity far beyond domestic naval requirements. Democratic values had created sustainable assistance through systematic naval aircraft sharing and strategic generosity programs that exceeded traditional military alliance approaches. Educational systems that produced American naval aircraft workers created human capital advantages through competitive academic development that exceeded traditional naval manufacturing methods and training approaches. Democratic education had produced technological capabilities through systematic knowledge development, merit-based advancement, and comprehensive skills training programs that enabled naval aviation manufacturing through civilian expertise rather than military organization. Technological legacy of American naval aircraft production influenced post-war naval aviation development through revolutionary manufacturing techniques, systematic design principles, and scientific quality control methods that transformed global naval aircraft production standards. Scientific advancement had created lasting advantages through systematic research and competitive innovation processes that exceeded traditional naval aviation approaches through civilian industrial expertise. Workforce development that enabled American naval aircraft success demonstrated democratic society's ability to mobilize human resources through opportunity and education, rather than coercion or authoritarian control. Competitive systems had produced naval aviation capabilities that exceeded totalitarian alternatives through inclusive participation and merit-based advancement that proved democratic advantages in naval industrial organization. Strategic implications of American naval aviation dominance included post-war maritime leadership that would influence global naval tactical doctrine through technological advantages established during wartime production programs. Democratic naval power had achieved systematic superiority through industrial organization and competitive manufacturing innovation that exceeded traditional naval aviation approaches through civilian expertise. The assembly line triumph had proven that democratic industrial organization could achieve systematic advantages over traditional naval aviation excellence through competitive innovation, systematic manufacturing, and abundant production that totalitarian naval systems could never match through centralized control, ideological motivation, or authoritarian resource allocation alone in naval aviation manufacturing and maritime warfare. If this incredible story of how American assembly line naval aircraft production overwhelmed German naval aviation excellence through systematic abundance amazed you, make sure to subscribe for more tales of democratic industrial triumph.